The Pythagorean theorem. This is one of my favorite units just because of all the really cool vocabulary words. The first one is Pythagorean. Pythagorean is named after a philosopher and mathematician named Pythagoras, and he was the one that came up with this idea, this Pythagorean theorem. And to introduce this, I've got a weird picture of some shoes that look like feet, and they really gross me out. The Pythagorean theorem itself says that anytime you have a right triangle, and you'll know it's a right triangle from that right angle in the corner, that a squared plus b squared is c squared. A and B are the legs of the triangle. Those are the short sides that come together for the right angle. And we'll talk about C and then C is the hypotenuse, or the longest side of your triangle. It's always directly across from that right angle there. So A and B are legs, and they're interchangeable with each other. But the hypotenuse, which is another one of my favorite vocab words here, is the longest side, and it's across from the right triangle. So A squared plus B squared equals C squared. What the heck does that mean? So basically it means that however long side A is, if I make that the length of the side of a square, and however long B is, if I make that the length of a square, that those two squares added together equal the amount of squares that you would need for C. So if I look at this, if I've got some amount of squares, like tiles, that are needed to make up this side length here, and some amount that are needed to make up this square here, that would be the exact same amount of tiles that would be needed to make up this big giant square over here. So let's look at that with something that's a little bit easier to comprehend, starbursts. Here I've got a right triangle, and I didn't label it, but there's my right angle in the corner there. And this side here is 1, 2, 3, 4 starburst high, and this side is 1, 2, 3 starburst long. So if I take this and turn it into a square, well, I've got 4 starbursts there. And if I make that a 4 by 4 square, that'll look something like this. Here I've got 3 starbursts. Well, I need to make that a 3 by 3 square. Then this side, my hypotenuse, which is across from that right angle, is 1, 2, 3, 4, 5 starbursts in length, which means it's a 5 by 5 square. So if I take all the starburst from the orange and the red, that's the exact same as the amount of yellow. So here, if I move the orange starburst over, and then I move the red starburst over, that completely covers, or is the exact same amount as the yellow starburst in the beginning. So let's see this in action. We want to find the length of this hypotenuse, that side C, to the nearest tenth. So I'm going to start with my formula. A squared plus B squared equals C squared. Again, C is across from the right angle. A and B are interchangeable, so I could use 3 for A, or I could use 3 for B. It's not going to make a difference. I'm going to go ahead and put that in as 3 squared plus 4 squared equals C squared. Again, I could have done 4 squared plus 3 squared equals C squared, and that still would have worked. C is the only one that has to be in its specific spot. Order of operations, we have to do our exponents first. So 3 squared is 9. 4 squared is 16. So that's C squared. Then we'll add those together. 9 and 16 is 25. And I don't care what C squared is, I want to know what C is. So to get rid of C squared, I have to take the square root of each side. Now, the solving equations with exponent stuff that you did yesterday, you know that there are 2 answers to this. C can actually equal a positive or a negative 5. But we're dealing with an actual shape here. You're not going to owe 5 centimeters for a side of a triangle. So because you are not going to have any negatives, we'll just write that as C equals 5 centimeters. Example 2, same kind of thing. I've got an A and a B. They can be mixed up. C has to be the side across from the right angle. So I've got it as A squared plus B squared equals C squared. I put 5 in for A and 6 in for B, although I could have switched those. 5 squared is 25. 6 squared is 36. Add those pieces together. Let's see, 5 and 6 is 11. So that's going to be 61 is C squared. Again, I don't care what C squared is. I want to know what C is. So I'm going to take the square root of each side. Square root of 61 to the nearest tenth, I don't know what that is off the top of my head. So I'm going to go ahead and use a calculator. So I've got square root of, oops, got to do that opposite on this one. So I'm going to do the square root of 61, which gives me to the nearest tenth 1 decimal place. The number behind it is less than 5, so I'm going to keep it the way it is. So that's going to give me 7.8 centimeters. You have 4 homework problems for tonight. Again, A and B don't matter. C is the only one that matters. You have some decimals here for squaring, but you may use a calculator on this section. Show your work. Have a great evening.